Hi, my name is Bojana Miloradovic Parman. I know very hard to pronounce. And I'm an advising VP product at Cogni. We're an AI memory company, and we are an open source company with a lot of contributors and very active in the open source community. We have 8.8 thousand GitHub stars, lots of active contributors. We're outpacing a lot of other memory projects in terms of the speed of contributions and activity. And we have about 300,000 pipelines running live at 47 customers. So this is an open source project, but with a lot of adoption and some maturity. Today, we're going to discuss what Cogni focuses on for AI memory, because there are many different areas of focus, but a lot of people think about AI memory as just a conversation between your program and a large language model. And if my model is smart enough, I just talk back and forth from my agents and everything works out perfectly. Well, this whole summit is dedicated to, well, we need some memory. Okay, we need to understand the paths of this conversation. But what my talk focuses on is you need way more than that. And because of some intrinsic things that exist in large language models and in the way the past conversations are composed, you'll need more to achieve the level of accuracy that is critical for the success of your production grade system. And why I focus on production grade systems. So in the past years, I've been working in engineering for 20 years. And one of the last companies I worked for was a large scale personalization. I was in data engineering, principal engineer running on that. And I noticed what level of problems arise when you move into the real AI situation at large production scale. It goes way beyond just a few steps that are needed for demos. So with that, let's look at some of the things that happen that exist as a controversy. So why is large language model not enough? There's an accuracy controversy around AI. So generative AI, we love it, we embrace it, it's phenomenal, it's smart. However, there's a controversy. Every time something new appears or predictability, it'll catch its attention, and that's its strength. And they say attention is all you need to focus on the right part of that. That's when you're talking just to the model, however smart it is. However, accuracy controversy, you may get something you're not expecting from that. And so this controversy around accuracy with large language model is the key reason why a different memory structure and what we can inject into memory is incredibly helpful into getting accuracy at the level that agents see. So let's look at the agentic AI. So unlike a one-on-one conversation where just one person is interacting with a large language model, as you're putting your agents into production at scale, this accuracy becomes even more important. Why? Because it compounds over the conversation turns and interactions among agents. So you have two different levels of compounding. One, as the conversations progress in the multi-turn way between agents and the model. And the second, as the conversation progresses among the agents themselves in the multi-agentic system. So as this error compounds, the result is further and further away from where it needs to be, and accuracy becomes actually on the critical path for this. And so our thesis at Cogni is that we, through AI memory, we can inject that accuracy back into the system. And LLM being as they are, as that guy on the mic, are behaving exactly how they should be behaving. But we can look at the memory layer to give it what it needs to become production grade. And so our theory is that it's all driven by relationships, relationship first approach. What are relationships? They're little snippets of dependencies or reasoning, little steps of reasoning that are firm and controllable and that provide accuracy. And on the theory that when you inject enough of these steps, you can reach the accuracy you need, or you can control the accuracy you're getting from the model. We provide a solution where the final outcome will be way more accurate than what you would need, than what you would get by just directly interacting with model. Now, let's step back for a second. You say, okay, so if we just provide the record of past interactions in the multi-turn conversation, whether it's by a human or different agents, wouldn't that be enough? So you just put that in the context and with some smart prompting. Turns out it's not enough. If you run any of the industry established benchmarks to check on accuracy, say Hot or Music or Locomo, you'll see that that's not enough. And so finally, we'll also suggest that in addition to reach the top level accuracy, there is some collaboration needed from the application teams, where you can inject relationships into the graphs and from there get the level of accuracy needed. So if you look at it in its entirety, memory is not a chunking problem only, it's an ontology problem as well. And so Cogni has a couple of different modules that help it deal with this reality of systems in production. We've got data ingestion modules, entity extraction, which is probably closest to what you do when you try to talk just to LLM to get the extraction of everything. Then we have some self-improvement layers, which I'll discuss next, and some other ongoing tuning that makes LLM ready context for agents. And only after you have all of these different modules in place and you make them tunable is when you can get to the level of accuracy that is needed. And so basically, when people start, how do we design? So let's talk about how we design these systems, how we measure them, how we optimize them, how we deploy them in production. So when designing, the first impulse people have is to put in some smart prompts into LLM and have LLM generate the original graph, which is fine. That's a good first start. And there are whole libraries that exist for this. For example, Instructor library by a popular person called Jason Liu does it very well, but that's your first step. Second step, okay, people realize, well, we need to put in some chunking and retrievers. We need to do the similarity on graphs. We need to put in some better prompts to reinforce the LLM to extract some of the missing links and missing nodes. So you try that, you tune your prompts, you provide some templates, you keep pushing that model. Is that enough? Again, no. If you go to production, you'll see this is not enough. Then the next step, people realize, oh, we need to actually tune these hyperparameters across the end-to-end pipeline. So what do? We inject some Bayesian dependency inside. We use tree-structured parsing estimators. We use the encoders, different encoders. So for example, the text encoders, the text model is horrible in math. We need to compute a little bit of something. So we inject a different encoder, different model. To deal with categorical and continual values, and so on and so forth. The things get complicated if you're trying to increase accuracy. And again, by trying the benchmark, you will notice how these things start popping up one by one. So that's all you need to be able to design it. So once it's designed, you need to go through an automated hyperparameter optimization process. And again, it is the ingestion, graph building, retrieval, and the prompts all together that need to be tuned in this process. Then you cannot just go brute force through it. You have to get smarter than that. Because just searching through all the combination of these parameters, you'll never finish in real time. So what you do is educated trial and error guessing. And one of the things you do, you use every possible heuristic that is known to you about your domain space and inject some ontologies. In other words, some graphs or some dependencies or relationships that you already know existed. So you don't have to depend just on the model to infer these patterns. If you know some patterns, you also give it to the model. And all of these things are needed to make things work in production. So search space, again, is going to be your chunking size, your retriever type, strategy used to retrieve content. Are you going to retrieve chunk level summary? Or are you going to retrieve original chunk based on embedding similarity? Then are you going to use graph completion? Are you going to push the model to extract graph triplet and then give it the subgraph and see, or are these two subgraphs looking alike or not? These are all the things that need to be done during the phase of hyperparameter tuning. And so we've done all of this and published a white paper on how to optimize this interface between knowledge graphs and LLMs. And I encourage you to take a look and see what happens with accuracy and how what were all the hyperparameters that we need. So that was the first step that helped productionize these systems. There are subsequent steps, but let's look at how we need to measure end-to-end system to see if we're there yet. So data sets that we used were Hotpot, 2Wiki, Multi-Hop, Music, Locomo. Those are all good to try. The metrics used were exact match, F1, and DeepEval, basically an LLM judge to judge whether the responses were good, and we're using a certain number of trials per run. So that's one way to measure the singular interaction, but you're building a multi-agent system. So now there's a whole bunch of measures that need to apply to how these agents interact. So how you want to measure the effectiveness of that system. So you wanted to get it to capture the transfer of patterns. For example, if you have a pattern around logging in, but people are authenticated and logging in 50 different ways, you want your multi-agentic system to be able to catch on to those patterns and recognize. Then you want it to be able to transfer between workflows. So that's the first one that is totally different than what you see in the benchmark, but it's going to hit you first when you deploy your multi-agentic system. Then you're going to measure the number of loops that these agents go through. So what they'll do is they'll try different things, and that orchestrator agents are going to start looping through different scenarios. You want to see whether it's doing too many loops or what is it doing. Then you're going to look at safety. Okay, are they all going into some direction that is unsafe for the enterprise? And so you're thinking, okay, we've got the workflow patterns, loops, safety, it can pattern match. This is great. But then what comes is time to resolution. Okay, how did my multi-agentic system resolve the actual issues? Then how many times did you have to escalate to human? That's another measure that you're going to have to resolve during these trial runs. And so when all of this is taken in consideration, those are the comprehensive measures you need to have to put these systems in production. Now, there is hope. All of this is solvable, and advanced AI techniques, some of the tuning, plus some of the good old software engineering can solve all these problems. And what we are trying to offer at Cogni is a framework so that that software engineers with a little bit of advanced AI can solve all of these problems and reliably put into production highly accurate systems. Okay, moving on, governing these systems, what does it take? This is very familiar to anybody who's put any system in production. You're going to need to have some roles. You're going to need to have multi-tenant data set isolation, auditing, logging, not leaking of privacy information, API key management, etc. You know it all. Then deploying it, again, the usual ilities. Is it monitoring? Is it observable? What's the data quality? What are the feedback loops? Then also the systems design issues like, oh, is it caching well? Is it scaling well? Do I have it in batch and real-time mode? Then am I deploying it on cloud? Am I deploying it on the edge system? All of these matters when you're going live in production. And finally, this memory system needs to be able to support the ongoing learning over time, keep the graphs and relational data updated with new interaction to optimize the end-to-end agentic system. And so that's all it takes to put this into production. Once you have it, you're good to go. It's working well, it fulfills its promises. And so that's what we're all about at Cogni, live open source project. Give it a try. We have SaaS offering. You can go log in and try it. You can download an image and play at home and your desktop. And we also integrate with all kinds of graph or vector stores and the agentic frameworks, Llama Index, LangChain, the LangGraph, etc., Cursor, Crew AI. We have YouTube videos showing you how to integrate with those. And that's it. Do you have any questions?